So I think we can get started in the meantime, probably with some introduction to the context of this seminar. I'm Elizabeth. I'm a postdoc working at Patrick Haggard's lab in UCL in London, and I'm very happy to chair this meeting today, which may be the first one in a seminar series if this goes well. So the initiative came from Richard, who's going to be our first speaker today in the context of last year's Neuroscience and Free Will Conference that happened at Chapman University about this time of the year, 1 year ago. And the idea was that it would be nice to have a space where philosophers and neuroscientists could discuss from an interdisciplinary perspective questions that are relevant for the question of free will. So today we're going to have two talks, two 30-minute talks. Richard's going to be our first speaker, and you will hopefully have received a handout with some notes about the topics he's going to cover, about 3 levels of internal generation. And the way that this is going to work, as I said, is we're going to have 2 30-minute talks, and at the end of those talks, we'll have 30 minutes for questions. So if during the talks you think about a question that you'd like to ask, you can use the raise your hand function on the chat that you should have, or you can type your question on the chat. And then when it's question time, I will be handing over the turn for people to ask their questions. I will also interrupt Richard and Patrick when 5 minutes are left for their talk. So we'll try to keep tight to the allocated time, and the whole thing should last for about an hour and a half. So without further ado, I'll just hand over to Richard. And yeah, there we go.
Okay, lovely. Well, thank you very much. I hope people can hear me fine. Let me know if I need to change my volume level. That sounds all right? Okay, good, good. So this is slightly backwards to the way I was expecting it, because Patrick was talking about his interest in thinking about free will through notions of internal generation. And I said, great, you can talk about that, and then I will say, make some responses. But now we're the other way around, which is an interesting decision for you. So when I started reading through this, the literature that Patrick sent me, I did the standard philosopher's thing, but it struck me that there were actually quite a few different things going on here. And I thought that I could just start by just disentangling those 3 things. Well, at least 3 as I saw it. Doubtless other people will see more levels than I've seen. I probably won't take 30 minutes. This will probably only be 20 minutes or so, but let's see how we go. Okay, so in the Passingham piece, which Patrick cites in several of his writings, talking about the difference between internal generation and external generation, one of the models he draws on there is basically Skinner's distinction between operant and classical, or operant and respondent conditioning and learning. And I think that's a good place to start. And there is stuff which Passingham has developing those ideas. There's also the stuff which Brems has, another participant in this bigger group, with tethered Drosophila. So I thought I'd talk a little bit about that stuff first, because I think that's a really nice starting point for this. So probably many people are familiar with this protocol, but the idea is that you glue a little tiny hook onto the back of Drosophila. And this is really quite technically remarkable thing to do, I think. And then you tie them by a little string inside a ping pong ball to minimize the degree of external cue that they get. And then you make it so that the angle at which they fly is a determiner of their environment. So what you have here is a very nice way of looking for a very pure operant conditioning, which doesn't involve any kind of external cue, like a lever in a Skinner box, which itself could be read as a kind of classical cue. So you get something that's very, very pure within the operant framework. Very nice. And what he finds from that, very interestingly, I think, is that there are very clear differences between both the kinds of behaviors which Drosophila show when they're cued in that environment, and the behaviors and the internal configuration of their brains when you put them in an environment which also involves classical cues. So if you make it such that the color of the environment which they're in also changes at the same time as their direction of flight changes, that gives them mixed cues because they're now getting both their own internally generated movement and they're getting an external cue on that. If you do that, what you find is that the neurophysiology is different to the case where you do it with purely with the direction of flight controlling the temperature that they're experiencing. And also, very interestingly, it's behaviorally different. So you get increased perseverance in the case where they don't get the external cue. You get earlier perseverance. It seems to move into a habit mode faster than it does if they are getting mixed internal and external cues. So, you know, clearly there are two very different things going on there when they are kind of self-generating behaviors from their own, on the basis of their own earlier behaviors, as against when they're generating behaviors on the basis of what they've seen from outside. So to some extent, you might think, and I think Passingham thinks, that this is a kind of model for an internal generation of behavior. But note, it's only internal in very specific ways. I mean, what's really happening here is that the environment is still determining what they do. So the Drosophila don't like it too hot. And if they fly to the left, it gets hotter. So after a little while, they learn to fly to the right. And that keeps it nice and cool and pleasant for them. So they're still, in a way, responding to the environment. It's just that the environmental information they're getting is coming subsequent to their behavior. So you can think that what they're basically doing, and I'm guessing this is what they're doing, is that they behave randomly to begin with. And as a result of that random behavior, they then pick up on patterns of what's nice and what isn't nice. And that then enforces a certain kind of behavior thereafter. So they are responding to the world. It's just that they are responding to the world via different neural pathways to the way they would be responding if it were classical conditioning, if they were getting a cue up front to begin with. And so, of course, because the reward is, the information is coming subsequent to the behavior in each iteration, you need numerous iterations before they can learn. But there is a way in which this is still externally generated behavior, using a different pathway to the externally generated behavior happening with classical conditioning. Okay, so let's go on and see if we can find stuff which is more internal. And I think this is more the kind of thing Patrick had in mind, and probably will say more about this when he talks about model-based learning later. But philosophers for the last 100 years or so have made a big distinction between inductive learning and what's sometimes called abductive learning, or sometimes called inference to the best explanation. So both of these are non-monotonic learnings. They're both unlike deductive or non-monotonic reasonings. They're unlike deductive reasoning. You can, all the premises can be true, and you can add more premises to them, and you can then change your mind about what's going on. But as models of induction against abduction, classic things would be induction, sort of Humean thing, you know, that the sun's come up every day up till now, therefore you form the hypothesis it's going to come up tomorrow. Abductive, the classic thing are things like Bouvet's discovery of Neptune. So it's not that he saw Neptune. At that point, Neptune was not visible with the apparatus that we had. It's rather that he was looking at Uranus, and he found there were these strange perturbations in Uranus's orbit. And, you know, very bright guy, very smart idea, thought, wow, if you posited another larger body further out that had a gravitational pull, then you would find that kind of behavior. Now, that's not inductive, right? It's not that he'd seen many other cases like this and thought there's another one of those. He was reasoning from certain bits of evidence and trying to put together some kind of story that made sense of that. So let's stick with the term abductive reasoning for that. Now, quite how that works, of course, is highly controversial. But learning of that kind is not like, I take it, the learning that's there in the Drosophila. The Drosophila, you might well think, we're using basically random behavior plus inductive learning to get to the knowledge that they should fly in a certain direction to control the temperature. Whereas Bouvet was not using anything that looks very much like that. So that strikes me as something which is very clearly something which we can think of as internally generated. in that, at least it's generated internally with more machinery from the inside than is needed for the inductive reasoning. Is it model-based? Well, I take it is model-based, right? I mean, it's kind of explicitly model-based in that he was working with an explicit model there. That said, a lot of the stuff which we think of as model-based is still, I take it probably best understood as a kind of inductive learning, sophisticated form of inductive learning. So if you look at Dawes' influential two-stage Markov model, where you have one decision to make at the first stage, and then you have a second decision to make at the second stage, and there's a probability weighting on the first one, and what you should do on the second one is dependent on what happened on the first one. And you need to know that your behavior on the second one is radically different to what happens on the first one. So you've got to work out a model, at least it seems that you've probably got to work out a model in order to get to the right kind of behavior in that case. Yeah, that's true. But we can still think of that as basically a kind of sophisticated inductive reasoning. It doesn't seem to need anything in addition to basic iterated induction across different cases. Whereas this other kind of abductive learning looks to be of a radically different kind. So I think the distinction between model-based and model-free is not going to cut at the same points as the distinction between inductive and abductive. I suspect that inductive is going to be a mixture of model-based and model-free, whereas the abductive is going to be entirely model-free. But I'd be very interested to get people's thoughts and observations on that. There's probably a big empirical literature there that I'm completely ignorant of that people can talk to me about. Okay, third case, and this is again stuff which came up partly from talking to people in the some Californian conference, the Chapman conference, but also coming out of some of Patrick's experiments and other people's earlier experiments. Most of the literature talking about abductive reasoning basically thinks of it in terms of using the reasoning in an instrumental way. So the basic thought there, you have your ends fixed, and you're now in a position of trying to work out what to do in order to maximize the satisfaction of those ends. And abductive reasoning helps you work out what are the best things to do, right? I mean, if you're in the business of planet observation, then that bit of abductive reasoning would help you look now for the position of this likely new planet. A lot of philosophers, starting with Hume, or at least instanced by Hume and very, very many other people since, have thought that really reasoning is only ever about means and never about ends. So the thought is that the ends are endogenously given, they're not given by, where endogenous there means non-reason-based given. And of course, for many people, classical utilitarians, there's a single end, and there's a single end for pleasure or something like that. And all the other ends are basically instrumental ends in the attainment of that. Okay, that's a beautifully simple and elegant proposition. I mean, the stuff I've done with Ken Berridge on addiction, which we can talk about if people are interested, I think shows very clearly that we can't think of ourselves as entirely pleasure motivated. We've got to think of ourselves as the motivational systems are much, much more complex than that, and they're using many, many different features. So ends, they're going to be multiple ends. And once you've given up on that kind of classical hedonistic line, I think, the question of them being things that you reason about starts to become extremely open again. And that, I think, just lines up with most people's everyday experience. So coming on to some of the experiments that were, again, making me think about this, Patrick and other people have these nice cases where you're given a choice paradigm, and the choice paradigm involves you making a choice between different charities. You can give money to different charities. It could be that, and I think in many of the protocols people were actually working with, people basically already had prior views as to who they would give it to, given the kind of choice they were offered. So they're offered giving it to Planned Parenthood or the NRA, I think was one case. seems unlikely there would be very many participants in one of these experiments who wouldn't have prior views of which of those two was the more eligible recipient. And given these were done in a university setting, I would have very strong priors on which the majority of gifts were, which of those two majority of gifts were being given to. But suppose we make a more difficult case. Suppose we give people a choice between giving money to local poverty or poverty in a developing country. Or suppose we give it between human-centered things, so alleviating poverty, and environmentally centered things, which are not human-centered. Those present real and difficult choices for most people. And I take it that people go in for a certain sort of reasoning when they're thinking about that. It'd be very interesting to know experimentally quite what that reasoning looks like. One thing, though, I think we should at least be suspicious of is the idea that the reasoning that they're going in for is the kind of Buridan's ass resolving indifference reasoning. Now, there's a standard philosopher's device for telling apart these cases of things that look antecedently almost incommensurable, and so the difficulty is trying to resolve is trying to make them commensurable from indifference cases, and that's what's come to be known as sweetening. So the basic thought is if you've got an indifference case, adding a small amount to one of the two options, making one of the two options slightly better, should be an immediate determiner. And so, you know, in the classic cases, here's the French kid deciding whether he should stay and look after his aged mother or go and join the Free French in the Second World War. It's a famous example from Sartre. Suppose she said to him, well, you know, if you stay and look after your mother, I'll give you another franc. The thought is that wouldn't have resolved the situation. In fact, he would think this was insulting. So it's not that he is poised equally between two options. They're on the same evaluative thing, and just giving a little bit of money pushes you one way rather than the other. It's that he's in the position of finding it very hard to put the two on the same scale. And he's doing reasoning that's trying to enable him to do that. Now, my guess is that that's what you're finding in the charity, that's what you would find in the charity case if you gave people some of these difficult charity choices to make. As I say, I don't know anybody who's actually tested this experimentally. It would be very nice to test it experimentally and see if, you know, if you changed it to sort of $500 and a cent for one as against $500 for the other, whether that people would just automatically think, okay, that's decided it, or whether they would rather think that's irrelevant, which I suspect is what they think. You know, the choice is still within us. And anyway, what are you trying to do with me? Fiddling with me with a penny here? I'm not going to be bought quite so cheaply. Of course, that's not to say that if you said, well, it's $1 million as against 500, people would change. The point is that they are insensitive to sweetening within an interval, and the bounds of that interval is something it would be, I think, probably just going to be experimentally tractable. Okay, if so, then I think we've got a kind of reasoning about ends which looks really kind of very deeply internal. So it's at least as internal as the standard abductive reasoning. If you believe strongly in the objectivity of reasons, as you know, philosophers like Scanlon do, then you might think actually this is rather similar to standard abductive reasoning. It's just you're doing it in a different domain. Take it that's wide open though. But I take it that almost everybody thinks that even if in some way this is subjectively based, if in some way preferences, something like that, are at the base of it, virtually nobody thinks preferences are at the base of it in a very simple-minded way. They think there's much more going on there than people simply giving voice to their preference. Now, you might do that in a basically preference-based setup, but it's going to involve a lot of additional reasoning along the way. So, is it model-based? Well, I take it probably is, but and we need to know a lot more about the nature of the choices made here and the reasoning that would go on to be clear on what kind of models it is. It clearly isn't model-free in the way that standard model-free accounts work. if it is internally generated, my suspicion is that this is one of the places where we're going to find very interesting stuff when we're looking for things that people might intuitively think of as sources of free will. Because this really does look like the kind of thing which morally and significantly in various other ways really, really matters, the kinds of choices and decisions that people make at this point. Okay, I think that's pretty much all I've got to say, so I will stop there and hand over back to Elizabeth.
All right, thanks, Richard. This was a very interesting talk and gave a very nice overview of different ways that we can think about endogenicity and internal states affecting behavior in a potentially voluntary manner. We're doing very well with time, which means that we will have more time for questions. I think we should anyway stick to the structure and now hand the time to Patrick to give his talk, for which I think he has the slides, and we'll share the screen so that everyone can see.
Thank you very much. Should I share my screen? Should I lead from this end, as it were? I'll try and do that. I think it can be quite tricky because once I'm showing my slides, I won't see anything else. So I'll be talking blind, I fear.
Would you prefer me trying to share the slides?
No, let me try it, but I just remember it can be difficult.
Patrick, you can see everyone else, I think.
You
should still see if you press the speaker view, then you will see everyone, I think.
Do I start the speaker view? Oh, I see. Speaker view in Zoom.
Yes.
Okay. So now I've started a share.
And can you see us?
I can see you on the right.
Yes.
But if I now start the presentation, I can still see you on the right. Okay, so the only problem is that I can't see you. Well, no, it's all working. It's going to be fine. It's going to be fine. Excellent, good. Thank you very much. This is really nice. And I'd just like to reiterate that this was Richard's idea. And Richard said to me at the Chapman conference that on this grant, he had all of this money and he was trying to think of a way to spend it. And his proposal was to have some joint seminars so that people could travel to and from the seminars, and this would be a very good use of the travel budget. Now, of course, unfortunately, the seminar ends up being completely free, so you won't use any of your travel budget this way, I fear, but it's perhaps better.
I should point out I didn't have a travel budget. It was a way of getting some of yours, so it's,
with
fine. No problem.
Well, I see. Well, you failed in getting your hands on my travel budget, but you've succeeded in what I hope will be a very nice event. So thank you very much for suggesting it, and thank you everybody for turning up and for hosting it. And I'm going to just start with a few initial observations and things that are sort of axioms, things that I need to get started in trying to think about internally generated action. So the first idea that I want to suggest is that all actions are caused. In fact, I think probably all events are caused, but we're talking about actions. So all actions are caused. So that means that if somebody does make a voluntary action, then there must be some cause of it. I'm taking it as axiomatic for the moment that dualism is false. And that means that when we're looking for the causes of voluntary actions, we're looking for some kinds of things, but not others. So we're not looking for souls, or we're not looking for mental states, if you understand a mental state as being something which floats free from the brain. So therefore, it seems to me that when we're trying to understand internal generation of action, we're looking for some particular mechanistic explanations about the causes of voluntary actions. And we're looking for internal causes rather than external ones. So what I'm going to do is spend about a couple of minutes saying why the idea of internal generation might be relevant to voluntariness or volition at all, because I think that's perhaps for some people controversial. I'm then going to go through some lists of possible causes of endogenous actions, and then I'm going to end perhaps a little bit like Richard did by coming back to this idea that we want somehow to get these ideas about the causes of action to link to ideas about responsibility or even morality. So what do you mean by volition? Well, that's a good challenge, and somebody challenged me to it recently. And in neurophysiology, in the sort of traditions of studying the nervous system, the critical way to define voluntary actions is to say that they're different from reflexes. So the history of reflex physiology is very beautiful. And Descartes was one of the pioneers, and Descartes, for example, suggested that thermal sensors in the skin would very directly lead this boy to make a muscle contraction, which would withdraw his foot from the fire. In the tendon jerk reflex, which some of you may know, the doctor will hit you just below the kneecap with a tendon hammer. The muscle is stretched, and the signal goes to the spinal cord, and then comes back to the that muscle, which then contracts, and your knee pushes forward, your lower leg pushes forward. I'm just going to change my pointer to one which is permanent because I find that much easier. So the key point about these reflexes is you don't really need a brain to do them. They come through the spinal cord. And this very interesting character, who's been unjustly neglected outside of the narrow circles of physiology, was perhaps the first person to really describe the wealth of reflex organization, and was also the first person to make the interesting proposal that voluntary actions might just be extremely sophisticated reflexes. So if you scale up these very simple kinds of organization of action, like this kick of the lower leg with the knee jerk reflex, maybe eventually you can get to something which we would say was voluntary. So that's one view. The alternative view is perhaps, rather than scaling, is an idea of contrast, and it's the idea that some actions are qualitatively different from reflexes. Some actions seem to involve a source of action which cannot be found in the stimulus. So the critical definition of a reflex action is that the motor response, the muscle contraction, is directly or immediately consequential to a sensory input, pain in the Descartes case, and stretch in this case with the tendon hammer. And sometimes it doesn't seem like that. So in the classic bird and ass situation, the two bales of hay are exactly identical. The donkey is hungry, and there's nothing in this bale of hay or in this bale of hay to influence its choice. There's no stimulus difference. It's a little bit reminiscent to the idea of sweeteners that Richard talked about. And some years ago, we pointed out that this sort of ambiguity or poverty of the stimulus has several aspects. So for example, in the bird and ass case, there's no information in the stimulus about what action to make. Sometimes there might be no information about when to do something. So there might be no external specification of the timing of action. That's, for example, in the Libet experiment. And sometimes whether you bother to act at all might be underspecified. And the intuition is that it's these cases where when you finally act, if you finally act, when you do choose one of these bales of hay, when you do choose what to do, it's not coming from the stimulus, it's coming from inside you. One bit of information is generated in your brain to say, go for the hay bale on the right. And it's that process of generating information which leads you to be the author of the action and thus perhaps become responsible. And Dick Passingham, who in many ways has been my mentor in this, in the 1980s did a very interesting series of papers in which he took this idea and defined what was often then called willed action, we might now call internally generated action or endogenous action or volitional action, defined it by saying the action is not driven by any external stimulus. So there's some things that might be unsatisfactory about this, but let me just say what's nice about this definition is it is rather formal. You could express it in terms of information theory, the number of bits of information or the reward value of two options. Richard gave the example of $500 versus $500.01. You can quantify whether there is information in external stimuli that would or would not drive the action. And most interestingly, he got some real neuroscientific traction on volition, in my view, by defining volition in this way, because in the human brain here, M1 is the primary motor cortex, which is where you find neurons that send the commands from the brain to the spinal cord and the muscles. And in front of the primary motor cortex, there are basically two broad zones within Brodmann's area 6, a lateral route, which is shown here as number 1, which is a sort of set of areas on the lateral surface of the cortex, which, speaking anthropomorphically, instruct the primary motor cortex what action to make when there's a stimulus telling you what to do. And on the medial wall here, the two hemispheres have been separated. So route 2 here from these medial wall frontal areas is specifically concerned with driving motor cortex when there is no external stimulation. So for actions that a monkey might make, but which are underdetermined by the stimulus. And neuroanatomy is so instructive. Here's a beautiful piece of work which I always cite because I think it's unjustly neglected, using cluster analysis to see what sensory areas at the back of the brain cluster together to link with what clusters of frontal areas at the front of the brain. So you've got basically your different sort of sensory dimensions here and your different sources of action here. And the medial frontal areas here in green are really interesting because they're the only action creating areas in the primate brain which don't have a big input from the parietal cortex. That's a clue that they're not driven by external stimulation. So this is just some neuroanatomical basis for the idea of internal generation has traction. And the problem is it's quite unsatisfactory because it's saying that voluntary actions are not driven by external stimulation. It doesn't say what they are or what they are driven by. It doesn't actually clarify the causes of the internally generated actions. It just excludes some other causes. So when we were recently asked, we were challenged to come up with a description of what do you actually mean by volition, and here's a set of things, none of which is necessary, but which might all be jointly sufficient, or some set of them might be jointly sufficient to make an action voluntary. So, or a mental state. If we take volition as referring to the mental state that produces voluntary actions, we might say, well, volition has to lead to movement. We've said it doesn't. It's not driven by external triggers. There's an idea that internal generation is in a bit similar to innovation. Can certainly be reasons responsive. It can be outcome directed, and it may involve consciousness. So these are sort of features that we might look for if somebody claimed to have found volition in the human brain or in the animal brain. And again, I think neuroanatomy is really important. All of these features of the sort of cognitive or psychic processes that generate action can be thought of as being constrained by brain architecture. So if I told you I had found volition in the brain, you might expect me to be pointing to a brain area which has only weak connections from sensory areas, which is not identified with subcortical habit circuits, but is strongly related to valence and reward, for example. And the key thing to highlight is that a big sort of subset of these putative features of volition are highly compatible with the idea of internal generation or endogenicity, or the idea that the cause of my action is not any immediate stimulus, because there's no sensory stimulus. The action is innovative. It depends on valence and reward, which might be coded internally. They might be coded in terms of internal values, and planning and monitoring. Those are things that happen in me rather than things in the outside world. So then I think what I wanted to try to do is to try to put my money where my mouth is, and to try to say, well, what might the causes of these endogenous actions be? So one of the sort of failures of the approach to volition as internally generated action has been an over-reliance on experimental studies and experimental methods where there is no stimulus, there's no cue which people respond to, but instead people are given some very odd instruction like press the button whenever you feel like it, which maybe in fact is just a kind of a covert stimulus. So there's been a sort of a lack of consideration about the causes of endogenous actions. And you know, going back to my starting point, so all actions are caused, dualism is false. We need some mechanistic explanations of the causes of voluntary action. So I'm just going to talk about three. I'm only going to talk about one at any length, but I'm going to talk about three. It seems to me that when people talk about the internal generators or the internal causes of action, there are possibly three different things or three different classes of cause that might be referred to. So the first one is very quickly dispensed with. The first one is changes in the internal milieu within the body, which might drive action in a way that is somewhat analogous to the way that the stimuli in classical reflexes, like the fire in the boy who withdraws his foot, or the tendon hammer in the person testing your reflexes, just the same kind of thing. So, for example, the stomach lining contains baroreceptors, which send signals to the brain when your stomach is empty. And in my experience, that might, not always, but it might be a good time to initiate the actions of eating. Now, it seems to me that that is actually formally and conceptually and cognitively pretty similar to many other reflex responses, like the knee jerk when you're hit with a tendon hammer, the withdrawal of the limb from a painful stimulus, and many other classes of reflex. So the fact that the sensory receptor is inside the body rather than outside, I think is not a good way to understand what internal generation of action means. And I consider that things like eating when you're hungry could at least sometimes be thought of not as internally generated actions in the sense that we are interested in them within this group, but rather as actions which are functionally exogenous. There is a sensory receptor. It happens not to be visible from the outside. It is interoceptive rather than exteroceptive, but a reflex pathway might still work. So these are covert exogenous stimuli. Now, these are actually probably extremely important, particularly for the people who do many interesting animal-based experiments on voluntary action. There's a lot of interesting work in that area right now, but I don't think they're really what we want to talk about at the moment. So I'm just going to sort of eliminate that and say that that's not relevant. The second class of cause of endogenous action is neural noise. So neurons are biological systems. All biological systems have noise, and the noise is sort of intrinsic to the biological hardware. And therefore, once you have neurons connected to muscles, you will have some internal noise in those neurons, and sometimes you will get actions because of neural noise. And I think we may have some slides on that. So we've already I'm going to just outline a cognitive neuro-ontology. We've already said that we're looking for volition as a process which produces action without input. And the idea of neural noise, of course, has been really influential in Aaron's work. So I'm hoping that may yield some interesting discussions. So the idea is that in a task where you have to make an action from time to time, but not at a very specified time, some neural noise might be accumulated and lead to you crossing this threshold. And the critical idea here is that readiness potential, which I'll explain in more detail on the next slide, should not be thought of as a readout of the consequences a readout of the consequences of a volitional command, but rather just a noise mechanism which happens to cause actions and which are thus clearly internally generated. So there's no specific process of volition prior to action, and the timing of voluntary actions is random and not caused. And I think what I find quite interesting about that is that then you don't need a black box called volition, if that's correct. But let's go back to the sort of final idea here. Sorry to back up. The final possible cause of endogenous action that I want to talk about is has been given a ragbag of names, and I don't want to commit to any of them very clearly, but these are all mental operations which are associated with some sort of cognitive control, prospective memory, goals, plans, models. I'm almost certain I've used the word model loosely and badly after Richard's talk, and I want to apologize in advance, and distal intentions. So we know, or you know, the work by Kornhuber and Dieker back in the 60s on the readiness potential that precedes voluntary actions. So here is the EEG prior to a simple self-paced action. And interestingly, they gave this rather strange instruction: make an action from time to time when you want to. So they're able to show that there's something which they interpreted as a process prior to voluntary action, and they interpreted it as a causal process. I think that's the key point on which Aaron's work disagrees, but they interpreted it as a causal process. And then the question is, what are they actually recording here? And what I want to, the reason really for mentioning the readiness potential at all is to draw your attention to an almost entirely forgotten feature of the Libet experiment and of Libet's 1983 paper. So in Libet's experiment, where he asked, like Kornhuber and Dieker, he asked people to make voluntary actions from time to time, he noted that there were two different types of readiness potential, which he called type 1 and type 2. Now, the way that he distinguished these, I think, is highly unsatisfactory, and we wrote a little commentary about this recently. But broadly speaking, he said that when people pre-plan an action, when they're doing something like ready, steady, go, when there's some internal process which is building up to the action of which they are, which includes some concept of conscious planning, you get these big early readiness potentials. Whereas when people made their actions, quote, freely and capriciously, I must say you do love the words that Benjamin Libet uses to describe his experiments are such a linguistic playground. I always like to quote from Libet because it's just really interesting use of language. You get these much smaller and later potentials. So the concept is that there's something about planning which is associated with activity in the medial frontal cortex and looks like a command and control mechanism, but maybe these free and capricious movements, maybe these are more linked to stochastic noise. So I want to tell you about one experiment that we've recently done, and this is an experiment based on the ancient art of cooking soufflés. So when Richard and I grew up, I don't know where you grew up, Richard, but in the United Kingdom, there was a big social thing about cooking soufflé because it was the way that you impressed your friends in the middle classes. And I've no experience of cooking soufflé, so I don't know how to do it. But what I do know is that you put the soufflé in the oven, and if you open the oven door too soon, the soufflé collapses, and your social kudos is profoundly reduced because your bourgeois friends are shocked. But if you wait long enough and then open the oven at exactly the right time, the soufflé is gorgeous and you get a perfect bake. So the task that we gave our participants was effectively a waiting task where you had to wait and press the button to open the soufflé at exactly the right time. And if you opened the oven too soon, then you got no reward. And if you opened at more or less the correct delay, I'll explain later, then you got some reward. Now, you can't just leave the souffle in forever, because then you won't make as many rewards during the 1 hour duration of the experiment. So crucially, there are 5 different ovens which correspond to these 5 different colors, and they have 5 different power ratings, so that the correct time to cook the souffle, in other words, the time you need to wait before you make the voluntary action, depends on which oven you're using. And the oven that you're using changes between one block and the next. So you've got to work out at the start of each block, how long should I wait before I act in this block? And the basic point about this is at the start of the block, being random, being stochastic, being free and capricious is really good, because it will allow you to explore the best time for action. And maybe you'll press too soon and you'll get feedback saying, sorry, you've burnt the souffle, no reward. And maybe next time you'll adjust and wait a bit later, and you'll gradually, by trial and error, learn the correct time for making the action. And as the block progresses, as you learn, once the correct time has been learned, then any stochasticity, any random noise in the system becomes dysfunctional. And what you really want is a model, at least in the loose sense that I mean, of how long you want to wait. You want an internal model of the oven and of the elapsed time that it takes to cook the souffle. That's the way to get success. So this is just people, this is the time during the experiment here, and this is how long they wait before they press the button. And each little gray block is a block of trials, which corresponds to an oven. So the first block, you should be waiting 9 seconds, plus or minus a bit. So there's a random zone around for what the correct time is around a mean, that's the gray bar, and the person responds too soon, the souffle gets burned, then they decide to wait longer, and then on the next trial they reduce the wait a bit, and they're just, as you can see, homing in on the correct time at which to act. Sometimes they never get there, sometimes some blocks they learn quite well. So the critical thing to notice here is that they vary the wait time before they press the button to open the oven. And if you look at the trials as a function of what happened on the previous trial, if you on the previous trial got a failure, you opened the oven too soon, then you will change your wait time substantially. So these are the absolute changes in waiting time following a failure. So once you've made a failure, you adjust your waiting time. Typically you wait longer. If you get a success, then you tend to stick with it. So this graph is just a way of showing that the update in the waiting time is a proxy for learning. If you screwed up, you change how long you wait next time. Once you've consistently getting rewards, you stick and you don't change your wait time anymore. And as the block goes on, the change in the wait time gradually reduces as people converge on learning how this oven behaves and responding at the right time. So I'm going to go fairly quickly. The point about this is it allows us to distinguish whether the readiness potential reflects planning, in which case the readiness potential should change from being small in amplitude to being large in amplitude as the update in your waiting time changes from being very big at the beginning of the block to being very small at the end of the block. So this graph shows a prediction about the effect of learning on the amplitude of the readiness potential, which is a little bit odd. Normally learning curves are presented like this as a function of time, but we think the critical thing here is not time, is not how many trials you've had, it's how much you're changing your behavior. We think of learning as the extent to which you're updating behavior. So if the readiness potential reflects planning, as you stop updating your behavior, the readiness potential should get bigger because you've learned a plan which will tell you exactly what to do. If the readiness potential reflects randomness, the opposite should be the case. You should get big readiness potentials when you're relying a lot on random exploration in order to find out what to do. So here's the result, and basically what I've done here is median split, or what Owen Travis has done, is to median split the readiness potentials that we recorded in this task according to whether each action is made during with a big change in the waiting time. In other words, you're probably early in the learning phase, or when the waiting time has become stable, which corresponds to the late part of the learning phase. And you can see that the readiness potentials are bigger late in learning when people are not updating their behavior than early in learning when they are. So the learning process seems to say that the readiness potential increases as you learn, which means it increases as the update in behavior decreases. So as we learn a model of the environment, and now I'm using model in this funny sense, which I suspect needs defined, we're going to people seem to use this model as an endogenous cause. People are using this model to trigger their action. And this is associated with learning the right time to act, with reducing stochasticity. Now, I've got about another 2 slides on responsibility. Do I have time for them, Elizabeth? Okay.
You have 5 minutes. Yeah.
Oh,
so,
good. Okay, that's more than I thought. Thank you very much. So I'm just going to go on to discuss something which is pretty different, I think. It's more concerned with how we can look at the relation between putative internal causes in the brain for voluntary action and responsibility. So I don't know whether I really believe this, but it seems somehow as though endogenicity of action is necessary, but not sufficient for responsibility. So in order for me to be responsible for the action, in some sense, it seems to need to be mine, or it needs to be mine in some sense of mine. And many systems of law hold people less responsible, or even not responsible at all, for things like reflexes. And also, interestingly, for actions that are so strongly exogenous in their causation that there doesn't seem to be much endogenous commitment to them at all. So an example of this, I'll just take this example because it was something we worked on a few years ago, is coercion. It's very famous. Moral and legal issue is very important. So these are experiments where sometimes an agent is told, you have to do this, and sometimes an agent can freely do this. And this, in the experiment, is administering a shock to somebody. So this person is going to administer a shock to this person. And what we found is that using implicit measures of agency, as we showed, we found that people have a reduced sense of agency under coercion, which is perhaps relevant to the idea that maybe people are not responsible when they're coerced. But that's just an example of the idea that strong exogenization of the causes of action, as under true cases of coercion, may be thought relevant to responsibility. So this is a completely unpublished but quite sort of interesting attempt that we made with Owen Travis and Sophia Bonacalci to look at different possible models, and they're fairly neurophysiological models of action causation, and to consider their relations to responsibility. So here's a sort of a readiness potential model, which I've called a command and control model, where you have some sort of will in your brain, we've called it the volitional signal, which suddenly says, will it now? And then there's a signal which looks a little bit like a readiness potential, which is caused by this volitional command and which leads to the response. There's another kind of model which suggests that our actions are just purely random and there's nothing like control at all. So just when this neural noise hits the threshold, you respond. Here is, I think, one version of a model a bit compatible with Aaron's work, where there's an initial something that pushes you up to near the threshold, so that the actual timing at which you act depends on a stochastic accumulated signal. And this is a really interesting and largely forgotten model by Eccles, which suggests that there's a random signal in the brain, specifically in the SMA, but there are little points where you get sufficiently close to threshold that free will can sail in a rather dualistic way and just tip you over. So there are these windows of action opportunity when you're close to the threshold. So the thought here is that you have different views of the noise in the system, which is low in this model, but high in all the others, and different views about the internal command. Does it exist? Does it come early, as in this sort of initial baseline shift in Aaron's model, or does it come late, as in the Eccles model, where the volitional signal comes in at the last possible moment to tip you into action? And what does this do for responsibility? So here's a try that we made recently. So on the x-axis, you see the time at which this volitional input, the command signal, is supposed to come on to occur according to these different models. So you can have some models where the command is early. So for example, in Aaron's model, the command comes at the start of the block. Maybe it comes when you go into the experiment, if it's in the case of the Libet experiment. I've put here veto models, because if you think that the key thing about free will is free won't and the chance to stop the action just before you pull the trigger, then that must be as late as possible. So the latest volitional signals are the ones mandated by veto models. And on the y-axis, you've got what is the amount of stochasticity? How noisy is the brain activity before you move? Is this a high noise system or a low noise system? So if you think that it's a high noise system, then you're up here on the y-axis, and then you're in a space where the noise is really a major part of what makes you act or not. And if you're a sort of a Kornhuber and Decker or a classic, I don't know, perhaps a Hegelian will, then you're basically saying it's all signal, it's not noise. And command and control models seem to me to be down here. So one intuition that we had is that if you believe in a classic idea of causal theory of action, of willed action, if you have a sort of Davidsonian idea that people have intentions which are goal-directed and make them act, then you really want to be down here in this bottom left-hand zone, which I've shaded in blue. We call that teleological intentionality. I think Sophia won't agree with me in my use of the term, but she and I are still fighting about that. And there's another interesting observation which we hope is correct. So if you believe something like the original stochastic accumulator model, then it looks as though the volitional signal to sort of allow yourself to get near to threshold might sort of make you responsible for the action that eventually happens, but not very directly, because it depends a lot on the noise that happens thereafter. And we wonder whether this might allow a useful concept of so-called derivative responsibility, that, yeah, okay, I allowed myself to get near the threshold, but that's only makes me derivatively responsible because the thing that actually causes the action is something later, and it's very much mediated by some noise which may not be directly under my control. So this is just a way to try to see how the different accounts we have of internal generation impact on responsibility. Here are my conclusions, which I guess I'll read. So at least one key class of endogenous actions uses a model. In this case, it's an internal model of an oven that bakes a souffle. I don't know if that's what other people mean by model. Involvement of this kind of model is what guarantees the endogenicity of the corresponding action. So in the experiment that I described you, it is because people have learned a model of the oven, of the way that this oven bakes souffles, this particular block. It's that which means that when they open the oven, when they press the button in the experiment, they're making an internally generated action. Now, interestingly, these models refer to the environment. These models are models of ovens, and an oven is part of the environment, and the model is acquired by interacting with the environment. So these model-based actions, when you've learned the correct time to act and then you act, I would say they're endogenous, but they're not solipsistic. They clearly are based on your understanding of the environment in which you live. So the environment is once again there It's not the direct driver of your action. What drives your action is your model of that environment, but the environment's there. And when you act, this is an interesting point, when you act on the basis of such a model that you've learned how the oven works, I think this seems still to require something like a command signal. It seems to be that you need to have some internal signal like, okay, I'm going to use this model. I know how this oven works. I know what to do now. I can plan my action for the future. You're into a type 1 sort of discourse where you need something like a command signal. When you have a plan, when you have a model, when you have a goal, when you have a distal intention, when you're acting through a reason, I just think it's tricky to get away from command signals. That's a nice quote from Richard, with which I want to agree. And I think what's interesting for me about the last part is, what's the relation between having a model of when to act or having a model of what to do and being liable to have responsibility ascribed to you? Maybe the model-based nature of an action makes it particularly susceptible to responsibility attributions. So when I'm blamed for burning the souffle, that only makes sense if I've got a model which I should have been using to open the oven at the right time, but wasn't. And that raises a question which I've always worried about, and I've never published because I'm really scared by its implications. That maybe when we ascribe responsibility to people, particularly when we blame people, what we're doing is we're saying, well, you made an action, and either you made it using a model we don't like, or we don't like the way that your model works, or there's something wrong with your model, or you're using your model wrong. And maybe responsibility is much more tied up with the process of having good models. It's as much tied up with the process of having good models, which are praiseworthy or blameworthy, as much as it is about making actions, or maybe responsibility is about the consequences of having models that we don't like. So I'd like to thank Owen Travers and Maya Friedman, who did the souffle experiment, and Sophia Bonacalzi, who has been working with Owen and myself on thinking about the relations of endogenicity to responsibility. Thanks very much for your attention.
All right, so thank you very much, Patrick, and thank you again, Richard, for the very interesting talks. So now it's the time for questions, and since nobody has so far raised their hand or written a question on the chat, I'll take advantage of being the chair and open up with the first comment and question while giving people the time to think about their next questions. So it seemed interesting to me that in the first talk, Richard drew a distinction between reasoning about means and reasoning about ends. And these potentially corresponding to different types of free will or control, or having different implications for responsibility. And I think that what Patrick presented, the experiment about learning, somehow taps on an aspect of reasoning about means. So in those experiments, the goal that people had was a given, which is also something that Richard commented. Many people assume is what's happening. We have no control over our goals. They are given to us. But what's important in Patrick's experiment is that people were able to pursue that goal by learning from the environment and then implementing some sort of behavioral regulation of that. And I think a lot of people would think that this is important, and this is sufficient to say that those people were behaving voluntarily. But a lot of people would also say that what actually matters is being able to choose whether you want to cook the souffle or not, and whether you want to have it perfectly baked or not. So basically specifying your goals. But to me, it has always seemed like a very experimentally intractable issue to determine whether people can actually control that. Whereas the learning approach and the reasoning about means, or the decision-making capacities that allow people to follow their goals, seems like a more feasible experimental approach. I don't know if you have any comment on that.
Patrick or me? Well, can I say one thing which I think is related to this? So on the concluding thing that Patrick talked about, you know, the extent to which responsibility involves sort of thinking we don't like your model. I mean, the standard view, which admittedly has been questioned a lot recently, is that ignorance is some kind of moral defense. So, you know, if you have a badly predictive model, and as a result, you take the souffle out at the wrong time, then, well, if it kind of isn't your fault that you've got the bad model, then it's not your fault for spoiling the souffle. So, you know, there's a presupposition that you have sufficient knowledge first, and it's on the basis of that knowledge that blameworthiness is now, or responsibility is attributed. Now, that's come under a lot of criticism recently. I mean, and it's certainly not straightforward. But it does seem to me it's not quite blaming someone for not having the model. It looks like the blame comes in when people have the model and don't use it properly, or they failed to get the model because they were insufficiently attentive and the model was perfectly available to them, but they just failed to do the work that was needed to get the thing. Which I think, you know, so tying that back onto the issues of well, no, let me just stop now.
I think one very useful feature of having two speakers and also a mute button is one can strategically fail to unmute and thus let Richard, or I can let Richard answer first. So thank you for that. Yeah, no, I agree with that. I think I was very interested in your idea about reasoning about ends. And I think that's something which is almost entirely absent from the experimental literature at the moment. I think typically the natural way to do experiments is to give people an instruction about what they're supposed to do. And at that point, you've done the reasoning about ends for them. You've given them a description of the task, and then they don't need to reason much about ends, only about means. I think you can imagine increasing task complexity. So you could have a task with more of a problem solving sort of element where people had to work out what the goal was and then try to achieve it. But that's quite difficult to operationalize in the experimental laboratory. It's a really nice challenge, and I'll have to see if I can think about how to do it.
Right, so I think, thank you. I think Till had a question next.
Hi, thank you. Yeah, I two, one for Patrick and one for Richard. So the Patrick question was, I wasn't quite, so in the souffle experiment, two elements go in. So the one is kind of an uncertainty reduction thing, and the other one is that there is the planning motivation, and I'm just not sure how the two are related and why they're necessary. So on your model, it seems that endogenous could be an action that's driven by an intention, so that you react different to stimuli depending on what your intention is. But I'm not quite sure why it's necessary to have a uncertainty reduction, or why uncertainty reduction or uncertainty at all in the task is necessary for endogenous, because planning and intentions don't seem to require uncertainty. So I'm still not quite sure whether I get that. And for Richard, the question was, so in the charity experiment, I wonder whether or not it's really true that you would find a Sartrean element of that a sweetener wouldn't work. Because I guess there's a one dimension that's missing, and that's there are hot and cold choices. And I think that perhaps even if you have two incompatible charities, you have roughly the same value, but you can't really distinguish between the two. As long as your choice is cold, I wonder whether a sweetener won't do the trick, because you do kind of think, oh, it's a Buridan situation. I don't know which one is better here. So if I get $1 more, I'll go for Amnesty, let's say, rather than Oxfam. But if you had to be involved in that charity, if there's a hot connection to that choice, I think you might need that to get a Sartrean kind of element to the choice. That's the two questions.
Shall I attempt, because your first question was addressed to me, so I'll try to be very brief. But I think this is about uncertainty. And I think at the start of the block, you don't know the correct time to act, so you are uncertain. And your ends, your task, is to make as much money as possible by pressing the button at the right time. So what you need is a plan for when to press the button. So thinking about it that way, a plan is a natural, or a model, is a natural way to reduce uncertainty. And I suppose people who like predictive coding and free energy would feel at home with that idea. So the thought would be that voluntary actions, I mean, just continuing in a sort of a predictive coding sort of way of thinking, that voluntary actions might be part of the way that we reduce uncertainty through acting. And I think the point really was that the existing literature on the neural precursors of voluntary action is a little bit ambiguous about whether this sort of special set of brain processes linked to volition are recruited precisely when you're uncertain, or whether they're recruited precisely when you know what to do. So both views have been proposed. So some people focus on the idea that when there's conflict and uncertainty, that's when you need cognitive control, and volition is all about cognitive control. That's a sort of Parashkev, Natchev, and possibly you could read that kind of thing into the Cohen-Botvinnik work, although they don't talk about volition. Whereas others have focused on the idea that the readiness potential is somehow about the understanding and having the perfect expectation and total certainty about when to act. And of course, learning is a process of uncertainty reduction. So that's the reason why the experiment is hung between these two opposing predictions about effectively about what the readiness potential is. So it's an experiment which is perhaps as much about the readiness potential as it is about volition, but that's the reason why uncertainty was involved.
Okay, shall I come in? Yeah, so apologies about the lighting. I forgot it was going to get dark, and I was hadn't arranged for there to be lighting.
We should have been in California, then it would be still glorious sunshine.
Yeah, there's contingency of the elements, which I wasn't factored in. Yeah, it'd be very interesting to know. I suspect that what you would find is that if you have let people deliberate and they've got kind of stuck, then adding a small sweetener will give them a way out, right? So they've thought, oh, I don't know what to do, and then suddenly you say, well, put an extra penny on, and you think, good, well, that's given me something to do. I suspect if you started with that extra penny already factored in, then it probably wouldn't have that impact. But we can try this. So even doing it cold, my suspicion is that if you start off with a very small discrepancy in the reward, but a potentially large discrepancy in which is the better charity, but you haven't really thought about it yet, then you're not going to look for that little sweetener. And then, of course, once that's already factored in, then my guess is you could fiddle with those sweeteners, and people still, because they'd already seen the sweetener and felt themselves immune to that, they would still not then be vulnerable to changes in that. But experimentally, it would be very nice to try. And I don't know. But I mean, the real thing was just trying to distinguish this from the Libet-style experiments, where they really are borrowed and ass situations, as Patrick was saying. Another little thing, as Patrick pointed out earlier, I should have said this was Uri and Liad's experiment and not Patrick's. Sorry, apologies for that. The charity experiment.
All right, so I think Aaron had a question next.
Yeah. Thank you for this very, very interesting discussion. Yeah, I have a question for Richard, and then I have a whole slew of questions for Patrick. I know I'll probably only have time for one or two of them. So Richard, regarding the whole sweetening idea, I think it's important, though, when you talk about sweetening, that you speak in the right sort of currency. So think about the case of Buridan's ass. If you laid a pound coin on top of one of the mounds of hay, I don't think it would make a difference for that ass because it's just not in the right currency. And I think in the example you gave about this person who could either go off to join the revolution or take care of his ailing mother, again, money isn't the right currency in that case either. So it might be that sweetening still is a valid concept, then it can tip the scales, but that the sweetener has to be in the right currency.
Yeah, good. No, I'm sure that's right. I mean, it's tricky, of course, in the Sartre case to work out what the sweetener would be. I mean, one thing you can do though is just give a little bit more information. You can add a degree of certainty. You know, you say, oh, it turns out you're going to make it out of France to the Free French. Now these are quite substantial sweeteners, in fact, so it's quite hard to get the incremental ones. But I mean, the lovely thing about your charity experiments is that because we're doing it with cash, it's already in the right currency, right? You can just change the amounts.
Right. In that case, you want to make sure that you have an experiment where cash is the right currency.
That's right. That's right. I think that's right. But that's the nice thing about the giving to charity. I mean, yeah, and it would be really nice to know what, whether there is a difference between these basically indifference breaking problems and these resolving what you're not indifferent to this, right? It really matters to you. It's not a case of the bird and ass. You think, well, I've just got to decide one way or the other, and it would be stupid to be stuck. It matters which one you get, and it would be very nice to know whether that is triggering different neurological features. Yeah.
So for Patrick, I had a couple of things. So one is just a point, a point for discussion. So in my view, neural noise is not at all the cause of action. It's something very ancillary. I guess I just wanted to clarify that. So for example, in my view of the Libet experiment, the cause of the action are the demand characteristics of the task. That's the cause. So if you brought somebody into the experiment and never gave them any instructions, but one way or another, they would never move. Well, they would move, they would fidget, whatever, but they wouldn't, press buttons or anything like that. The cause is the demand characteristics of the task, and that's actually built into the model. And what the role that noise plays is just to sort of tip the scales about when that action actually happens. So it's really something ancillary, but that ancillary role is enough for it to appear as this buildup in the average. So that's just a clarification, which you may want to respond to. I don't know, but
try to respond straight away to that bit, because yes, I recognize what you said, and that's very clear in the way you set out the model. And I guess the question is, what is the status of ancillary events for responsibility? That was the speculation that we were trying to do off the back of your model. So to the extent that the effect of noise is to produce a bit of jitter in when you follow some task demands, then it's ancillary and unimportant. To the extent that there is a large and notable variation in the wait time, during which, of course, lots of other things might happen. So during the period where there is a neural noise leading to a wait, the world might change substantially and things might all move on. And therefore, if there's a strong ancillary contribution of this noise mechanism, then what you do at the beginning of accepting the task demands, which I think in your model corresponds to this baseline shift, that's true, but that only potentially leads to the action that eventually gets made, or there's a lot of indirectness and there's a lot of stuff in between. The ancillary role of noise might begin to occupy a substantial part of the sort of causal space. And at that point, it seemed to us a little bit like the rather interesting case of intoxication in law, so we're not lawyers, but in many countries, if you do something when you're blind drunk, there's an interesting question about, well, why are you responsible? Because you might not remember doing it. You certainly didn't have conscious control of your actions at the time that you did whatever stupid thing it was you did. And then the idea is that, well, you're responsible because you opened the bottle and drank the whiskey. So you're derivatively responsible because of the enabling conditions which led up to the action. And you did control the enabling conditions, even if you didn't control the sort of chaotic, drunken mess that intervened before punching the person in the face. Now, I know that's not what you're talking about, and you're cautious not to talk, or you're rather sort of cautious about the issue of responsibility, but just trying to extrapolate the more emphasis one places on the sort of contingency and amount of the ancillary process, the more that seems to determine the responsibility status of the initial enabling, and it becomes just purely derivative. So, okay, I volunteered to take part in the experiment, but then there was so much other stuff which then happened that when eventually I pressed the button, I was it really me? That's the intuition.
Okay, thanks. I think I'll just I'll forego my second question and let someone else go, since we're short on time.
We have 2 or 3 more questions lined up. Next is Liat.
Hi. So first of all, thank you. It was very interesting. I would say to Richard that probably Uri will feel the same, that this seems like a very interesting idea that we should probably look into experimentally, and maybe even these Corona times. This might be something that we can do online fairly easily. So let's discuss this more if you are interested. And I have a question for Patrick. So first of all, I was jealous to have not thought about an experiment with souffle, especially if it was a chocolate souffle. That is something that I should have done. But I wanted to ask about the logic behind the division to stages. So I completely understand why it makes sense for subjects to be random at the first stage and then stop being random later on. But I'm thinking what's happening at the cognitive or psychological level. And I think that what subjects might be doing is actually be occupied with planning in the first part and less so in the second part. Because what I would do probably is to say, okay, so now I waited 8 seconds, let's plan ahead what I'm gonna do next, and it didn't work, so I should now do 10 seconds and so on. So if you think about kind of deliberation, which is the way I think about these things, from that perspective, I think there is more deliberation and planning in the first part and much less so in the second part where you already know what to do. So now basically I'm now in the 8 seconds kind of range, and I have to pick in a way when I don't know if this is picking or not, but I'm just saying that I think there might be more planning at the first part, and then actually the hypothesis might be in the opposite direction. So I would like to hear what you think about that. I'll just say, I'll apologize that after you reply, I will have to go because I have another meeting, so I won't be able to hear the 2 other questions, and I want to thank everyone and the 2 of you for this interesting session.
Right, well, thank you for being here, and I'm sorry that you still got meetings at what I believe is 9:30 in the evening, or no, even 10:30 in the evening. Oh, yes. Poor thing. Well, don't work too hard. That would be something I would just suggest. So yeah, no, thank you very much. The credit for the experiment, I should just mention, really goes to Owen Travers, who might be on the call. I think he was on earlier, as much as more than to me, and he developed the idea. But I think, yeah, your comment's very interesting. So the thought really is, during learning, there's a process of plan creation or model acquisition, followed by model exploitation, where you're just deploying the plan that you've already got. So that's certainly a good point. I think that doesn't change the logic that we have, namely that we can ask whether any particular signal, like the readiness potential, is associated with the acquisition phase or the deployment phase. And it does look as though it's more associated with deploying. It's after you've learned the plan that you can, you have this stronger build up towards the action. I think we were trying to use the explore-exploit distinction in decision making, and I think that is applicable here. But you're right. Maybe planning is about plan acquisition, not about plan utilization. Yeah. So planning is perhaps not a clear enough word to use. Thank you.
Thank you.
So we have time for Owen's question and maybe Jake's if this one is quick. So Owen.
So thank you all, first of all. Two quick notes about the souffle first. We uploaded the preprint to bioRxiv over the weekend, so it's there if anyone wants to see it. And initially this task was the paint dry-in task, but that turned out to be a whole lot less fun. The questions I wanted to ask were about the first talk. Unfortunately, I missed the first couple of minutes of this. But before I was a voluntary action researcher, I was a reasoning researcher. And two things worth pointing out. First, there is an interesting literature on really the opposite of sweetening effects. So I think it's in Tversky and Shafir's work on reason-based choice that when you expect to see these sweetening effects, when you add something of small value to an option, it can reduce the value of those options. So I think that's worth looking at there. The bigger point I wanted to make was there's a quite commonly accepted idea in most of cognitive psychology now that these model-free or type 1 processes, or whatever we want to call them, are associative and operate on continuous representations like evidence accumulation or state spaces or feed-forward neural networks, while type 2 or model-based or reason-based processes operate on these discrete symbolic and syntactic representations. And the important point here is that you can't have a gradual build-up with type 2 representations. You can't gradually go from a state of not acting to nearly acting to acting, which is what we associate with the readiness potential. If we're doing reasoning, if we're deriving conclusions from premises, we can only do this with type 1 associative processes. So by that token, you would say that if the readiness potential really reflects volition, then actions based on reasoning are not fully volitional. They don't have that same build-up. They don't have that same preparatory processing. We talked about testing this, but ran out of time. So if anyone wants to explore that, I'm happy to talk about it.
Good, that's very interesting. Yeah, I would love to talk about that at some point. I mean, my suspicion here is that the folk concepts are not going to line up very neatly with the neurophysiological realities. So I think we might find that there are some things that are really helpful for the folk concepts and vice versa. But I'd be very surprised if we get anything that's lines up very, very nicely across the board, because I suspect there are a lot of processes going on which tend to get kind of just running together in case of someone making a decision or exhibiting volition. But yeah, I would very much enjoy talking more about that at some point. Yeah, let's do that.
Owen, although I don't think your question was directed to me, I've got a question for you. So I was very interested in that distinction that you made between the sort of continuous association based ways of thinking and the discrete syntactic ones. And you described it at a level of theoretical generality and sort of universal or basic axis of cognition, which I can't say I recognized. So I think this is a really interesting distinction, but I wonder if you could suggest a couple of references, maybe post them in the chat, about where one can get it. I mean, is this coming from the reasoning literature?
And in part, yeah.
Right, I'd find that really interesting to follow up. It's always seemed to me very difficult to connect the reasoning literature with, the finger that pulls the trigger, with the motor literature. And I do see an incommensurable gap sometimes when I try to link those two literatures together. So I'd find it very interesting if you could paste some suggestions to follow up reading. If you put them in the chat, I think they remain available for everybody.
Sure.
All right, so I think that with the promise of a follow-up reading, I would like to thank Patrick and Richard again for very nice talks, and thank everyone else for attending. I hope this was interesting for everyone. And I hope there will be other sessions of this seminar in the future. So thanks everyone, and hope to see you soon in future meetings.